Welcome to another solution with the physics tutor. This will be problem number 7 from chapter 11 in the Giancoli 7th edition of physics. Problem number 7 from chapter 11 reads, a mass m at the end of a spring oscillates with a frequency of 0.83 hertz. When an additional 780 gram mass is added to m, the frequency is 0.60 hertz. What is the value of m? So what we have is a spring that is oscillating back and forth with some mass m on it. Okay, so our mass is m, and it's oscillating back and forth with a frequency that's equal to 0.83 hertz. And then we add an additional mass to this oscillating system. So we have m, and then we attach to it in some fashion another mass that is 0.780 kilograms, or 780 grams. And when we do this, this entire system now is oscillating with a frequency equal to 0.660 hertz. Now, this isn't unexpected. We clearly know from the relationship of frequency, the relationship for frequency is 2 pi square root of k over m. 1 over 2 pi square root of k over m is the relationship for frequency. We can clearly see that m is on the bottom here, so it has an inverse relationship with frequency, such that when we increase the total mass in oscillation, the frequency is going to reduce. Okay, and what they would like us to figure out is, what is the mass of block M? Okay, we want to know what an actual value for this initial oscillating system was. Well, we still have the same spring. Okay, so this spring hasn't changed. Notice one thing that they don't give us in the problem is they don't give us the spring constant. We don't know what k is, and this is the same spring, but we still don't know what k is. However, if this spring and this spring are the same spring, these two k values are equal to each other. We can use that to our advantage. We can solve this equation for k, and then we can use that to set this system equal to this system and solve for m. So our first step is going to be to rearrange this equation for k. So f is equal to 1 over 2 pi, the square root of k over m. I'll multiply both sides by 2 pi, so that will give me f times 2 pi is equal to the square root of k over m. I'd like to get rid of the radical, so my next step then will be to square both sides. So the frequency squared times 2 squared, which is 4, times pi squared is equal to k over m. And then finally, I'm going to solve this for k. So I'll isolate it by multiplying both sides of the equation by m. So I will then have m frequency squared times 4 times pi squared is equal to k. This is useful because this k value for this particular problem is the same for both oscillating systems, the system where m is oscillating and the system where m plus 0.780 kilograms is oscillating. So I'm going to create two equations and set them equal to each other. One equation for this system and one equation for this system. So I'm going to write m times 0.83 hertz squared times 4 times pi squared is equal to this system, m plus 0.780 kilograms times the frequency of oscillation here squared, 0.60 hertz squared, times 4 times pi squared, and that is equal to this. And now you'll notice I have on each side of the equation, I have a factor of 4 pi squared. Can cancel that out. So now I can write m times 0.83 hertz squared is equal to m plus 0.780 kilograms times 0.60 hertz squared. Now I can square this value here. So I'll plug that into the calculator. 0.83 squared, that's going to give me m times 0.6889 hertz, and that's actually hertz squared, not this squared, but just the unit squared because I'm squaring the unit. And then I will have m plus 0.780 kilograms times 0.6 squared hertz, which would give me 0.36 in the units of hertz squared. Okay, now I've got a mass times hertz squared, and I've got a mass times hertz squared. The next step that I can do here is I can go ahead and distribute my 0.36 hertz squared into this. So I'll write m 0.6889 units of hertz squared is equal to m times 0.36 units of hertz squared plus 0.36 hertz squared times 0.780 kilograms. And that will give me a value of 0.36 times 0.78. That gives me 0.2808 kilogram hertz squared. Okay. All right. So now I've got mass times hertz squared and mass times hertz squared on opposite sides. So I'm going to subtract 0.3 m times 0.36 hertz squared from m times 0.6889 hertz squared. So I'm going to subtract this from both sides of the equation. And so that will give me 0.6889 minus 0.36. That will give me m times 0.3289 hertz squared is equal to 0.2808 kilogram hertz squared. And now to find m, I will simply divide both sides of the equation by 0.3289 hertz squared. Hertz squared will cancel. I'll be left with kilograms over here. And so I'll have 0.2808 divided by 0.3289, and that will give me a mass of 0.854 kilograms, which we will round to 0.85 kilograms for our final answer for what the mysterious mass M is. If this video was helpful to you, please like and subscribe. And as always, please remember to enjoy yourself while you're out there physicsing.